And so like I said, we'll do the first 4 together, and then I'll let you guys work on the other 4 on your own, and there are also some more practice problems on Edmodo. I'm never going to collect those, they're really for your own enjoyment, I guess. And then the plan on Monday, we're going to do a set of kind of harder problems, and I'll probably have a group quiz on Tuesday, and then see how you guys do and go from there. Alright, number 1. Car accelerates from rest at a rate of 1.9 meters per second squared for 14.7 seconds. The car then slams in its brakes and decelerates at a rate of 5.3 meters per second squared until it comes to a stop. What is the total displacement of a car? How many things are going on in this problem? 2. What's the first thing that's going on? Acceleration. What's the second thing? Deceleration. Ben, you sound so enthused about doing this again. Alright. So, for part 1, the acceleration, what do we know?
It's accelerating at 1.9 meters per second.
Yep. So we know A is equal to 1.9 meters per second squared. What else do we know?
It's accelerating for 14.7 seconds.
So our time is 14.7 seconds. What else do we know?
It started at 0.
Started at 0. So our initial velocity is 0. That's because it started from rest. Any questions on why we know those, or why I labeled them the way I did? Alright. What are we going to be looking for in this first part, do you think?
Delta X.
Delta X. I'm looking for delta X. Let's go ahead and find delta X. What of those first 4 equations over there has these 4 variables in it? Third one. So we're going to say delta X equals VOT plus 1/2 AT squared. Delta X equals, I'm just going to make this whole thing 0 because initial velocity is 0, plus 1/2, times our acceleration is 1.9 meters per second squared, times 14.7 seconds quantity squared. So what's our delta X? Yep.
205 meters.
105 meters. Alright. Alright. Any questions about how I got to that? Adam?
Just how do you want us to round those?
I'm going to say significant figures. I'm not actually going to care about it though. Like, round it to something that's reasonable.
Okay.
Does that make sense?
Okay.
Like, this technically should be 210, but I'm not going to mark off for that. And the AP test is not going to get marked off either. And really, for almost any physics problem you ever do, your answer should always have the same number of significant figures as the one that had the least here. But again, I'm not going to worry about it too much.
Okay.
Alright, let's look at part 2. What do we know in part 2?
Initial velocity is 13.9 meters per second.
question number 2, part 2.
Part 2.
Oh, okay.
What else do we know about the second part of this problem?
Decelerate, or acceleration.
Yep, so we know the acceleration is what?
Negative
5.3 meters per second squared. Everybody understand why it's negative since it's going to be slowing down? Alright, what else do we know?
Original velocity.
What?
Original velocity.
Do we know that yet? No. But we can
Well, we can find it.
find it. So wait 1 second, Ben. What else do we know about this part? What's our final velocity, Adam?
0.
Yep, so we know final velocity is 0, and we're going to be looking for delta x, so we can add it to this one and find the total displacement. Does that make sense? Is there any equation up there that only has 3 variables in it? We can't use that one. That one's only for no acceleration, remember?
Void.
What? 4? We're going to have original velocity in a second here. How can we find the original velocity for part 2?
By
The final velocity of part 1.
Yep, so we're going to find final velocity for part 1, and that becomes the original velocity for part 2. Does that make sense to everybody? Alright, so which of those 4 equations up there have final velocity, but using these 3 variables? We don't want to use our delta x. Anybody think of why we don't want to use delta x? James?
Because it's rounded off.
That was rounded off, and what happened what if we got this wrong? Then the other part's wrong too. So you try to, if you can't always avoid it, but if you can avoid using a number you calculated, avoid using the number you calculated, because you're more likely, if you made a mistake, then you've made 2 mistakes then instead. So what equation has VF in these 4?
Final velocity plus acceleration.
Yep. So VF equals 0 plus 1.9 meters per second squared times 14.7 seconds. And what's our final velocity? 27.9 meters per second. So that becomes original velocity over here. So now what equation can we use to find delta x?
Use number 4.
We don't have time.
We don't have to figure out
2, we don't have 5. Use VF squared equals VO squared plus 2a delta x. 0 equals 27.9 meters per second. Quantity squared plus 2 times negative 5.3 meters per second squared times delta x. Bring this over, so it's 27.9 squared. 770. So 8. That equals say, negative 10.6 times delta x. And what does delta x equal? 73. And what's our last step going to be? Add them together. So we'll say delta x total equals 205 meters plus 73.6 meters. We get 278.6 meters. Any questions about this problem? people could have done this on their own without me? You don't care. How many people just struggled with this on their own? How many people could do it on their own without me now? Good enough. All right. Number 2. Ball is thrown up with initial velocity of 13.9 meters per second. What is the highest point the ball reaches? So which set of equations are we using here? The blue ones or the green ones? Green ones because we're dealing with free fall and vertical motion. So what do we know, number 2?
Initial velocity is 13.9
Yep.
meters per second.
What else do we know?
Acceleration.
The final velocity is 0.
Yep, final velocity at our highest point is going to be 0. And so we also said we know our acceleration is going to be what? 9.8 meters per second squared. So what are we looking for here? Delta y. Alright, what equation is this for? Last one. So, b squared equals bo squared plus 2 g delta y. Velocity is 0 equals initial velocity is 13.9 meters per second. 1 squared plus 2 times negative 9.8 is delta y. And what does delta y equal? What is it? I picked awful problems for this worksheet. Alright. We're gonna skip to number 5. And then we'll do number 5 and number 6, and then I'll let you guys do the rest on your own. 5. Ball is thrown up with initial velocity of 8.3 meters per second. How long is it in the air for? Okay. What do we know in this problem? Initial velocity is, what does it say?
8.3 meters per second.
Alright, what else do we know? James?
Actually, I had a question. Are we assuming it's being thrown from the ground?
We're assuming it's coming back to the same spot.
Okay.
What else do we know?
The final velocity will be 0 meters per second.
Not in this case, because they're going up and coming back down.
Well, when it lands on the ground.
Remember, it's always right before it lands on the
Oh,
ground.
that's right,
before.
So this is
Is it going to be 8.3 or something like 8.3, but the opposite?
Negative.
Negative 8.3. When it goes up, it comes back down to the same height with the same speed, but in the opposite direction. Does that make sense? So final velocity is negative 8.3 meters per second. What else do we know?
acceleration is negative 9.8.
Yep. And there's one more thing we know, we don't need it, but what's our delta y? It goes up and comes back down to the same spot. 0. Alright, so we're looking for time for how long it's in the air for. So what equate? We can use a whole bunch of different equations here. What's the easiest one to use probably? Third one, I showed personal preference at this point, but VF equals VO plus AT is I think the simplest to use. So we get negative 8.3 for GT equals 8.3 plus negative 9.8 times T. So we get negative 16.6 equals negative 9.8 T. And what's T equal? 0.7. That's how long it's in the air for to go up and down. There's lots of different ways to do this problem. You could also figure out how long it takes to go up and multiply it by 2 to figure out how long it takes to go back up and down. So the time it takes to go up is going to be equal to the time it takes to go down if it's coming back down to the same height. Does that make sense? Okay. These free fall ones okay so far? Adam?
Why was it negative 8 times 3?
It's 8.3.
Okay.
So it's negative 8.3.
Oh, okay.
Sorry about that. My decimal point is a little high. Alright. Number 6. A falling stone takes 0.39 seconds to travel past a window 2.6 meters tall. From what height above the top of the window did the stone fall? Anybody have any idea where to start with this one? James?
Well, okay, so obviously say what we know. And then, so, trying to find delta y. We know acceleration.
This is another one we probably want to break into 2 parts.
Yeah.
What are the 2 parts? Tom?
We can find the velocity by what we get relating the seconds it took to pass through the 2.6 meters. So divide 2.6 by 0.39.
That would only work if it was constant velocity, but it's accelerating here. So what we're going to have is 2 parts. We're going to have above the window and window. Does that make sense? Why I'm dividing it up like that? Okay, what do we know about above the window?
Acceleration.
Yep, so we know. What else do we know about above the window?
Initial velocity is 0.
Yep, when it's dropped, its initial velocity is going to be 0. So we know VO is 0 meters per second. Don't know anything else. But what we're ultimately looking for in the problem is delta y for the above the window part. Does that make sense? Can we solve anything from that part right now? No. What do we know about the window part? Time is 0.39 seconds. What else do we know about the window? Delta y, 2.6 meters. And we still know that g is negative 9.8 meters per second squared. What can we find on the window part that will be useful to us for this part? The initial velocity for the window part is going to be what for the above the window? Final velocity. So if we find VO, we can use it over here as VF, and we'll be able to solve for delta y. Let's find VO. So what equation do we have we can solve for VO with? Second one. Delta x equals VOT is 1/2 GT squared. And so we get that delta y. 2.6 meters. Important thing here. Should have pointed this out earlier. Should delta y be positive or negative? Is it above where it started or below where it started? Below. So what do you think it should be? Negative. So delta y is going to be negative 2.6. we're looking for original velocity time 0.39 seconds plus 1/2 times negative 9.8 times 0.39 seconds squared. So we multiply that out, and what do we get? And divide, I guess, too. Yes. What do we get for VO? That sounds about right. Do you get positive or negative 4.0?
Negative.
And that makes sense because it's moving down. So whenever it's moving down, we're going to get a negative velocity. Alright, so bring that over here as VF. And now, what equation can we use to find delta Y? Fourth one, yeah, the VF. Okay, so we get VF is negative 4.8 squared equals 0 plus 2 times 9.8 times delta Y. You get negative 4.8 squared divided by negative 19, or 4.8 squared divided by 19.6. And what do we get for delta Y?
Negative 1.18.
And what we found there is how far it fell, so that's why it's negative. I wouldn't take off for making that negative in the final answer, but it means that it was dropped 1.18 meters from above the window. So if we figure out how far it fell, we can figure out from there. Questions on this one? Alright, while you guys try to do the rest on your own, I'm going to be around to help you. You can work in groups. The answers are in this binder. It says AP answers. And your answers will probably differ a little bit from what's in there just because of rounding. So don't, like, if it's 87, you got 86.9 or 85.9 even, that's fine.